Welcome to Study Loop.
Hello friends, here it is given heat pump cycle in which refrigerant is R134A. We have to find isentropic efficiency of compression, rate of heat supplied to the heated room, coefficient of performance of pump, and coefficient of performance of pump for heated room. If heat pump to be operated on ideal vapor compression cycle between the same pressure limit are to be determined. So given heat pump operated on ideal vapor compression between same pressure limit let us hear the analysis. We have to use fluid property of R134A using table A11 to A13. Let us see here. At state 2, pressure P2 is 800 kilopascal and temperature is 50 degrees Celsius. That is for condenser. Enthalpy is to 86.71 kilojoule per kg. Temperature T3 is the saturated temperature at the rate of 750 kilopascal to be 29.06 degrees Celsius. At state 3, P3 is 750 kilopascal and temperature T3 is 29.06 minus 3, that is 26.06 degrees Celsius, and enthalpy is 87.93 kilojoule per kg. In state 1, that is for pump, pressure is 200 kilopascal. Temperature T1 is minus 10.09 plus 4, that is minus 6.09 degrees Celsius. Enthalpy is 247.88 kilojoule per kg and entropy is 0.9507 kilojoule per kg per Kelvin. In state 2, pressure is 800 kilopascal. Entropy H2 is equal to H1 and enthalpy of saturated fluid is 277.28 kilojoule per kg. Isentropic efficiency of the compressor. Entropy in state 2 in isentropic process minus H1 upon H2 minus H1. Putting the value 277.28 minus 247.88 divided by 286.71 minus 247.88. So it is to be 0.757. The rate of heat supplied to the room to be mass flow rate of fluid into H2 minus H3. So mass flow rate is given in the problem 0.022 kg per second into 286.71 minus 87.93. So it is to be 4.373 kilowatt. Power input can be defined as mass flow rate of working fluid into H2 minus H1. Now putting the value, mass flow rate is given 0.002 kg per second into 286.71 minus 247.88. So it is to be 0.8542 kilowatt. Coefficient of performance would be rate of transfer of heat to the room upon power input 4.373 upon 0.8542, that is 5.12. The ideal vapor compression cycle analysis. Enthalpy in the state 1 is equal to enthalpy of the vapor at the rate of 200 kilopascal, that is 244.50 kilojoule per kg, and entropy in the state 1 is equal to entropy of the vapor at pressure 200 kilopascal, 0.9379 kilojoule per kg per Kelvin. Pressure in the second state P2 is 800 kilopascal and entropy S2 is equal to S1 having enthalpy 273.29 kilojoule per kg. So enthalpy in state third to be equal to enthalpy of the fluid at pressure 800 kilopascal 95.48 kilojoule per kg. Hence, coefficient of performance to be H2 minus H3 upon H2 minus H1. Putting the value from the above, we can write 273.29 minus 95.48. 273.29 minus 244.5. So it is to be 6.18. Now rate of transfer of heat at high temperature. Mass flow rate into H2 minus H3. Mass flow rate is given 0.022 into 273.29 minus 95.48. So it is to be 3.91 kilowatt. That's all for it. Thanks for watching it.